Okay, we've got some more notes on topic 7, and the topic here is right triangle, question mark. So we are actually going to figure out if our triangle is a right angle. We don't know if it is or if it isn't. And what you notice is that all of the side links are given to us. So we know that we can only use the Pythagorean theorem if it's a right triangle. But I want you to think of it also as if it's a right triangle, the Pythagorean theorem will work. So we're going to use our Pythagorean theorem of a squared plus b squared equals c squared to try to determine if these triangles are right triangles. So what we're going to do is we're going to square all the sides. That's what you're going to do first. And so if I go through and square all these sides, if I have 7 squared, I know that's 49. If I have 24 squared, I know that that value is 576. What are you doing? You're taking 24 times 24. And if I square the number 25, I get 625. And so if this is a right angle or a right triangle, then we know the two smaller sides would equal the larger. So let's try it. Does 49 plus 576, does that equal 625? And it is either yes, a right triangle, or no, it is not. And this example is yes. We can put the right triangle symbol in there. So that's what we're doing, and I've got 4 examples. So let's just move on to the next example. The next one, same thing. We want to see if it makes a right angle. So we're going to square all of our sides. So 3 times 3 is 9, 4 times 4 is 16, and 6 times 6 is 36. Your 2 smaller sides, well, the smaller ones are 9 and 16. Do those together equal your larger? And on this one, 9 and 16 is 25. Does that equal 36? No, it is not equal, so we will not have a right triangle here. No, not a right triangle. Let's look at our last 2 examples. The reason these last 2 examples get a little tricky is because you see on number 3 here, we have a square root symbol. And we're still going to go through the same process. We are going to square all of our sides. What that means is times it by itself. So 8 times 8 is 64. And the square root of 26 times the square root of 26. The square root and the squared symbol actually cancel out, and your answer is 26. And same with the square root of 28 times the square root of 28. That cancels out, and your answer is 28. So the question here is, do the 2 smaller sides, which would be your 26 plus 28, does that equal 64? And the answer to this is no, 54 does not equal 64, so this is not a right triangle. We are using literally the Pythagorean theorem, a squared plus b squared equals c squared, to check and see if these make right angles. Let's look at the very last one, and what you notice with the last one is that they gave you 3 sides, but they just used commas. They didn't give you a picture here. That's okay. We can still square all 3 sides. So 10 times 10 is 100. And then my next side is the square root of 205 times the square root of 205. When you times it by itself, that cancels, and you just get the number 205. And if I do the same thing for the last one, the square root of 105 times the square root of 105, that cancels, and you just get 105. And so we need to make sure that we add the 2 smaller sides. That's the Pythagorean theorem. So does 100 plus 105, does that equal 205? And this is yes, a right triangle, meaning it has a 90-degree angle. So to summarize this and go back to our essential question, how do I determine if a triangle is a right angle? Well, you're going to use the Pythagorean theorem. You're going to square all of your sides. You're going to add the two smaller sides and see if it equals, and when I mean equals, exactly equals the bigger side. And if it does, then your answer is yes, a 90-degree triangle. And if it doesn't, the answer is no. If you have decimals with these, I'd write out all of the decimal just to be accurate. That's it. Squaring numbers, determining right triangles. Have a good one.